Okay. So our next speaker is Dr. Jean-Pascal Matteau. Jean-Pascal is a professor in field crop systems at the Université de Laval in Quebec City. His research program focuses on developing innovative, data-driven approaches to optimizing water management and crop protection under changing climatic conditions. He's worked extensively on the development of an integrated irrigation approach for potatoes, which allows for optimal potato yield, water use efficiency, and minimizing the environmental impact of irrigation. So we asked Jean-Pascal to come talk to us today about optimizing irrigation in potato production.
So thank you, Ryan. Usually I don't use a mic. I have a voice that is enough, but I will use the mic for the video. So yes, as Ryan said, I'm Jean-Pascal. I'm working on irrigation management since the start of my PhD, so a couple of years ago. So we'll talk about optimizing irrigation for sustainable potato production today. So I'm going to talk about the potato production in Quebec and how it adapts to climate change and to water stress especially. We'll talk about the principal methods to decide when to irrigate. That's the central part of my work, trigger points to start irrigating, the decision making behind irrigation, and some research results and future perspectives. So starting, climate change is hitting hard on the producers. More and more around the world, water scarcity rather than the lack of arable land is increasingly recognized as the most pressing limitation to agricultural production, especially water stress. Areas of irrigated potato are increasing all over the world. In Quebec, it's a really strong trend, and this trend is likely to be maintained due to climate change and increasing food demand. Potato crop is really efficient in terms of calorie production per water drop, but potato crop is also really sensitive to water stress because, as you know, the root systems of potato is really shallow. The development of roots are stopped by tuber initiation, so the majority of roots is in the first 20 centimeter. This combined with the high vegetal biomass, it's created a really high evapotranspirative demand, so we need a lot of water to grow potatoes. So for the Quebec potato industry, we have a little more than 700 producers on a little less than 20,000 hectares. A lot of the revenue are from international exports. There are three main regions around Quebec, around Lanaudière, in Saguenay-Lac-Saint-Jean, that is more in the northern part of Quebec. We have a little bit of a nice distribution of the potato markets. A lot of the production is going for the table potatoes. We have a little bit of chips and pre-peeled, and a nice seeds production in Saguenay-Lac-Saint-Jean. In the northern part, there are some certified producer I'm sure you're aware of. But the most interesting part for the irrigation management is the irrigation context in Quebec. So the irrigated potato area are really increasing a lot in the past few years. So from 2010 to 2022, it more than tripled. So now we are, in 2022, in fact, it was 37% of the total area that was irrigated. I've heard of data of 2024 that were more close to 50% of the area that was irrigated. So it's really a strong increasing trend that I guess will be maintained in the future. And some regions are already experiencing conflict of use, especially with the domestic and industrial water use. Even if we have a lot of water in Quebec, we consume also a lot of water. And for agriculture and potato production, it needs really enormous volume. Some producers are already equipped with irrigation ponds, so they just store water and store especially snow melting water. But in some regions, it's even not enough. Most producers use sprinkler systems. Most of them use sprinkler systems. Some use drip irrigation, especially in seeds production. It saves around 35 to 40% of water, but it's really more expensive to use than sprinkler systems. So my objective today is to present, the lessons from Quebec that could be relevant to Prince Edward Island producers, and to discuss and present some of the research findings that we had in our group and some other groups, and the tools that can be applied at field scale here, as much as in Quebec. As you probably already know, there's a lot of benefits to irrigating the potato cropping systems. Those kind of data that, okay, here's a pointer, that I'm showing here are pretty, classical. Sometimes we see on the, on the x-axis here, it's, evapotranspiration on total yield. Sometimes we see soil water content. Sometimes we see soil metric potential, but the trend is always the same. If there's, under application of water or water stress because of drought or dry soil, we see really a drop of yield. And if there's an over application of water or too much water, loss of yield too. So there's an optimal zone to have the best yield you can have, or to reach the yield potential of your variety. So we see that all the time in all the trials. There are some factors to consider when you decide to irrigate. First, the soil type. Sandy soils, as you know, require more frequent water. So smaller and frequent irrigation are a nice strategy in sandy soil. When you are in clay soils, as it retains more water, we require less frequent irrigation. Growth stage is really important. We can manage irrigation by maintaining the same comfort zone for all of the season, but between the tuber initiation and tuber bulking, water stress is really the more damageable to yield, so between 30 to 80 days after planting. Surely weather conditions are really important when you manage irrigation. High temperature, wind, and low humidity increase evapotranspiration, so you need to put more water to meet crop water demand. So the main part of the presentation, what are the principal methods to decide when to irrigate? So there's a lot of companies that, selling or renting sensors, soil sensor and everything, selling services to help producers to know how to irrigate. I'm not, entering with what are the company are selling, but more what is the science behind their service. So the first way to decide when to irrigate is the older approach of visual observation and gut feeling. And as much as aware of, a lot of producers working that way. It's not, it's not bad. It's kind of working. So you go doing some visual crop or soil inspection and observe plants for signs of water stress, such as wilting, leaf rolling, or leaf temperature. The leaf are always colder when they are well irrigated because of evapotranspiration. So you can, get a feeling of your crop and how it needs water by doing that. The problem with this approach, it's really connected to the producer and connected to your crop, but the intervention you made is always after the appearance of water stress. So you are always a little bit late. So you can lose yield because you are too late. And surely it can lead to over-irrigation or under-irrigation, which means yield loss. One of the more classical method, another old method, it's more of an accounting method. So you can calculate evapotranspiration, so you estimate how much water your plant is losing through soil and transpiration from plants. So you can measure it, but it's pretty hard to measure. It's easier to calculate using, temperature, wind, and other climatic variable. So you can calculate that to schedule irrigation. So both methods are working well together. You can use only evapotranspiration, you can use only scheduling, but if you combine evapotranspiration and soil-water balance, it's working, better. In the soil-water balance method, it's another accounting method. So you just take the water inputs you have, so the irrigation and the precipitation, and you compute the losses by evapotranspiration and drainage. And on a daily or weekly basis, you determine what is the soil water deficit and you irrigate that quantities. So people are doing irrigation management that way for the past, 60 years. It's working. It's not overly precise, but it's working. But that's not one of my favorite methods because it's look more like accounting than agronomy, and it's kind of far away from plant needs. But it can work, and it's really, cheap. Another method that is more and more used by potato producers, it's been used by strawberry and tomato producers for the past few years, is base your decision on soil measurements. So there's two main soil measurements that you can use. Soil water content using either TDR, electrical sensor, or capacity sensors. And you can use soil metric potential, also called soil tension, using tensiometers. So both measurements can work. Usually what the company will sell you are soil water content sensor because it's really cheaper to make. But I find it's also less accurate. For you that are not familiar with the curve that I'm showing, it's a soil water retention curves. We're using it when we try to measure soil water content and soil metric potential together. So you see in the y-axis is the soil water content, and it's the soil metric potential in the x-axis. And I'm showing you this curve because that's really the reason why I prefer soil metric potential to soil water content. So as you can see, like the data here are all the threshold that I tried in my PhD, so between 7 kPa to 45 kPa. And so a tensiometer is precise at 1 or 2 kPa, and you can have like all that range, and all that range is, between over irrigating and not enough irrigation for potatoes. And it's on soil water content axis, it varies by like very few, it's almost imperceptible. So when you use soil water content sensor, you're in a range so small that usually sensor can even, see that's change. So it's really hard to manage irrigation with soil water content because of that. TDR are able to do that, but the other one are not. And if you want to, buy the capacitance sensor on Amazon, really not working. The pros of that method is it allows intervention exactly at the right moment. So exactly when your plant will be stressed, you can know it and irrigate. But it's localized measurements because you're measuring soil water content or soil metric potential on a specific point, and you can't take into account the heterogeneity of your field. So that's one of the challenge of that method, and you need really precise trigger points that are specific to your soil type. Other methods that are used more and more is the remote sensing based method. So you can use camera with multispectral or thermic data. mounted on a drone or a plane or everything that is flying. And you can use a lot of indices to manage your crop that way. One of the pros is that you can see the field heterogeneity, either of your soil or your crops. So you get some map like that, like those one. Those are NDVI maps, so you can see that part of the field. There's a problem here, and the plants are vigorous or really green, so it's going better. So you can, manage your zone like that. For irrigation, it's tough to manage in some specific zone with different irrigation thresholds or anything, but you can do it. There are, drip irrigation that can do it, or sprinkler systems that can do variable rate application. But the challenge with remote sensing methods is that the diagnostic is really hard, because a lot of abiotic stressor or even biotic stressors can lead the data that you see in your images. So you don't know if it's water stress that you are seeing, or is it an illness, or is it another problem in your field. So it's really hard to do the diagnostic and say, oh, I need to irrigate. Maybe you don't need to irrigate. Maybe the problem is, an insect or an illness. So that's why now the remote sensing is not used a lot to manage irrigation. Usually producers say, like, drones take really beautiful images, but I don't know what to do with it. So those are the principal methods that you can use to, decide when to irrigate. But all those data are not useful if it can lead to, action. So the data is not enough, even if you work with soil water content, soil metric potential, or remote sensing. The data is one thing, and taking it to actionable insight is the next step. So that's the step you need to take to make informed decisions. So you need to integrate like the technical, economic, and environmental consideration in your decision making. And as I said, the most important challenge in that is acknowledging the spatial variability of the soil, the crop, and the water conditions, and surely economic and operational constraints for the growers. So there's a couple of ways to base your decision-making approach. I think that the easiest to use for the producer is the rule-based decision-making approach. It's the cheaper one, and it's easy to manage. So you decide to irrigate when you got information. So if you use soil tension, for example, you can say, okay, I irrigate when my sensor reach minus 15 kPa. The advantage is it's really easy to implement. It's relatively low tech. It's cheap, and it can be easily automated. So it's really easy to put a computer in to say start my sprinkler systems at that trigger point. However, it lacks some adaptability, so it will start even if we are forecasting a rain in 1 hour. So you need to manage that risk, and it needs a precise trigger point. So talking about trigger points, there are different ways to build trigger points. I think that for potatoes, the easiest way is to manage your crop into a comfort zone. So you just avoid water stress. So we've done those work in my labs, in my PhD, and now in my labs as a professor. So usually I work on marketable yield because that's what the growers want. So I just focus on marketable yield. And what we've seen is that marketable yield is maximized between minus 10 and minus 24 kPa. So as you can see, and I was saying earlier, like if you over irrigate, so at zero, the soil is saturated with water. So if you over-irrigate it, you receive a really hard drop of yield. And if it's too dry, yield drop too. So we've seen the same behavior for multiple varieties and in multiple studies from my lab and other labs. We've worked especially on table potato varieties because it's the most used in Quebec. The most used variety in Quebec is the Gold Rush one. I've made a lot of studies on this one. So my hypothesis is that the variety that are, genetically related to produce the same types of tubers have the same trigger points. So I want to validate that hypothesis, but from at this point, -10 to -24 have been really in a working comfort zone. If you want to aim for the highest water productivity, you need to stretch this zone and stay around -24, -25. And you can see really there's a lot of yield increase if you stay in that comfort zone. And I like that management by comfort zone because that's the point. As a researcher, we always search for significant difference, but that's not what the growers want. The growers want the best yields, and that's what I'm looking at. And what we've seen in those works, it's that it's really the time spent into a comfort zone that will, lead to the yield increase. So that's why when you over-irrigate, the yield loss is worst because you spend less time in the comfort zone. You are always too wet. When you are too dry, you spend some time in the comfort zone while the soil is drying. So it's less of a problem if you're a little bit too dry than if you're overly wet. This is some field observation that we've made. We've worked a lot on greenhouse. We've worked a lot in controlled trials, but we also done field observation at producers' fields. So those are two results of different observation. In one of my observation, we've been doing irrigation management by soil tensiometers, and we made 26 irrigation between the 1st August and the 17th of December just to keep the potatoes in that comfort zone. So it can be really, really, really dry if you don't manage your irrigation. And this is an example of a producer's. It was almost at the same time, so it was a week and a half in August. And as you can see in the blue rectangles here, it's supposed to be that comfort zone. And you see here an irrigation. And I don't know why that producer was managing his field that way, but his sprinkler system, his pivot was not fast enough because he did an irrigation here and it was really, really way too dry. After that, he was for a couple of days in the comfort zone, but it took like 10 days before he can do an irrigation. So his potato was not in the comfort zone enough time, and it was too dry, really, really too often. So this is what we said to him, like, you're not you're not irrigating enough, and you need to come back faster to irrigate. Another aspect of the trigger point is when you determine your lower threshold. So when you stop your irrigation, there's a couple of ways to determine that lower threshold. If you're using soil sensor, you can install soil sensor, under the root zone, and you can determine a threshold under the root zone. So your root zone is in a good comfort zone, and you stop when you're starting to lose water that can be used by your crops. or you can use a timer. I find it easier to use a timer because you have less sensor to manage in your field. So by your expertise, you decide the duration of your irrigation. Usually it's between 1 hour or 1 hour and a half. And for drip irrigation, I have more experience in drip irrigation. And then you stop and you can see your soil sensor reacting, and you decide how many times a week or a month I need to irrigate to keep my crop into the comfort zone. So this is the work I've done in the impact of potato irrigation. We are talking a lot about crop yields because that's the most important part, but just so you know, there are other impacts of managing irrigation. So you can have an impact on the degradation rate of soil organic carbon. You have an impact on soil microbial community, on water use efficiency, of course, and you can have an impact on tuber depth. So if you over-irrigate, the tuber are closer to the soil surface, and if your soil is dry, the tuber tend to be deeper. So it can have some impact on soil degradation and of your operation. We are also working on other stuff that are impact with irrigation management. So probably we'll have other results to publish in the months to come. Just a little slide before my time is passed on the next work that we will do in our labs. I think the next big thing to manage stress in especially potato crops, but other crops too, will be the digital twins. This is a method of modeling crops. So you're using a crop that you're monitoring, and you create a virtual dynamic representation of that plants of interest, and you use the bidirectional data flow between the two to iterate and increase the accuracy of your model, and you can unlock predictive capabilities by doing that with the large data sets that you create and the machine learning and the artificial intelligence that you're using in your modeling. So it enables early anomaly detections and what-if scenarios. So if your plant is not behaving like your model, you can detect that something is going on before your eyes can see it. And you can try what-if scenarios. So what if I'm irrigating or not irrigating? Will it have an impact on my yields? So I think this is the next big thing in irrigation management. And we are doing other works in my lab. Just rapidly, we're working on all abiotic stress. So we have a couple of projects also on nitrogen fertilization in potatoes right now. So thank you for your attention, and thank you.
Thank you. We have time for 1 or 2 questions for Jean-Pascal. Any? Yep, Jonathan?
What's your average application of water? Like what would you consider to be an application of water? Half an inch of rain, an inch of rain?
So the question is, what would be the average amount of irrigation per pass on the?
Usually I don't work with amount of water, more with soil sensor. So I try just to reach my lower thresholds, not like the quantities of water, because I found it's less precise to work with the amount of water. Prefer to work with the soil measurements.
Any other questions? Over here.
You showed a chart that kind of talked about keeping the crop in the optimal zone for a certain amount of time. I was kind of curious what the x-axis was. Was it days or weeks?
I think I lost control of my slide.
That's okay. And I think what's kind of behind my question is just, do like, so there's sort of a range from crop is too dry, too wet, and then there's kind of a sweet spot in the middle. Do you feel like the curve is quite peaked, or it's pretty broad? Like, as farmers, we're seeing that too dry, too wet. A lot of us are relying from rain in the sky.
Yeah.
And there's always variability in what we get. So as we're planning irrigation, do you feel like it's hard to stay at the optimal range, or is there a pretty big band in there where as long as your water's coming roughly when you need it and roughly in the right amount?
Well, once you have an irrigation systems, I think that if you build it well, it's well engineered, you can stay in the comfort zone almost all of the season. All you need to do, it's easy to say, but is to keep it, your soil water content stable. So that graph is a percentage. So if you stay more than 60% of the time in the comfort zone, as I observed, it was, kind of enough. 60% to 80% was enough to have, the optimal yields. So relying only on rain, you're surely not going to be 60% of your time or more into the comfort zone. But if you have an irrigation system that is well engineered, you can trigger it just when you need it.
Okay. Thank you very much.
Thank you.
Jean-Pascal. There's a little bag for you there.
Thanks.
Okay.